Good day, everyone. I am Shalu Jazel, Prayer by Ron. Welcome to my presentation. As you can see on the screen, our topic today is reliability and individual scores. Here is the topic outline and the intended learning outcomes. Reliability and individual scores. The reliability coefficient helps the test developer build an adequate measuring instruments, and it helps the test user select a suitable test. The usefulness of the reliability coefficient does not end with test construction and selection. By employing the reliability coefficient in the formula for the standard error of measurement, the test user now has another descriptive statistic relevant to test interpretation. This one useful in estimating the precision of a particular test score. The standard error of measurement. The standard error of measurement, or SEM, is a measure of how much measured test scores are spread around a true score. The SEM is especially meaningful to a test taker because it applies to a single score and it uses the same units as the test. The standard deviation of a theoretically normal distribution of test scores obtained by one person to equivalent test. The tool used to estimate or infer the extent of which an observed score deviates from a true score. The relationship between the SEM and the reliability of a test is inverse. The higher the reliability coefficient, the more often a test produces consistent scores. Note that the reliability coefficient ranges from 0 to 1 and is calculated by administering a test to many individuals twice and calculating the correlation between their test scores. To illustrate the utility of the SEM, let's revisit the Rochester Ranch Works, or TRW, and reintroduce Mary, who is now applying for a job as a word processor. So to be hired at TRW as a word processor, candidate must be able to word process accurately at the rate of 50 words per minute. The office administers 7 brief word processing tests to Mary over the course of 7 business days. In words per minute, Mary's scores are 52, 55, 39, 56, 35, 50, and 54. Which is her true score? So true score is the individual score on a measure of if there was no error. So which is her true score? The true answer to this question is that we cannot conclude with absolute certainty from the data we have exactly what Mary's true word processing ability is. We can, however, make an educated guess. Her true word processing ability is equal to the mean of the distribution of her word processing scores plus or minus a number of points accounted for by error in the measurement process. The best we can do is estimate how much error entered into a particular test score. also known as the standard error of a score. The standard error of measurement is an index of text to which one individual's scores vary over tests presumed to be parallel. In accordance with the true score model, an obtained test score represents one point in the theoretical distribution of scores the test taker could have obtained, but where on the continuum of possible scores is this obtained scores? If the standard deviation for the distribution of test scores is known, and if an estimate of the standard error of a particular score can be determined by the standard error of measurement is equal to the standard deviation of test scores by the group test takers, square root of 1 minus the reliability coefficient of the test. Standard error of measurement allows us to estimate in which the true score is likely to exist. So, consider spelling test has a reliability coefficient of 0.84 and a standard deviation of 10. Then, the standard error of measurement is equals to 10. Square root of 1 minus 0.84 is equals to 4. Another example. I have another example. Suppose an individual takes a certain test 10 times over the course of a week that aims to measure overall intelligence on a scale of 0 to 100. They receive the following scores: 88, 90, 91, 94, 86, 88, 84, 90, 90, and 94. The sample mean or the average is 89.5 and the sample standard deviation or the square root of the variance is 3.17. If the test is known to have a reliability coefficient of 0.88, then we would calculate the standard error of measurement as the standard error of measurement equals 3.17 square root of 1 minus 0.88 is equals to 1.0.98. So in order to use the standard error of measurement to estimate the range of the true score, we make an assumption. If the individual were to take a large number of equivalent tests, scores on those tests would tend to be normally distributed, with the individual's true score as the mean. Because the standard error of measurement functions like a standard deviation in the context, we can use it to predict what would happen if an individual took additional equivalent tests. So approximately 68% of 68.26 of the scores would be expected to occur within plus or minus 1 standard error of measurement of the true score. Second, approximately 95%, actually 95.44% of the scores would be expected to occur within plus or minus 2 standard error of measurement of the true score. Third, approximately 99%, actually 99.74% of the scores would be expected to occur within plus or minus 3 standard error of measurement of the true score. So, of course, we don't know the true score for any individual test taker, so we must estimate it. The best estimate available for the individual's true score on the test is the test score already obtained. So, if a student achieved a score of 50 on one spelling test and if the test had a standard error of measurement of 4, then using 50 as the point estimate, we can be 68% confident that the true score falls within 50 plus or minus 1 standard error of measurement, or between 46 and 54, including 46 and 54. So, ang formula nito is score plus or minus standard error of measurement. So, the score is 50 and the standard error of measurement is 4. So 50 minus 4 is equals to 46 and 50 plus 4 is equals to 54. So 95%, actually 95.44% confident that the true score falls within 50 plus or minus 2 standard error of measurement, or between 42 and 58, including 42 and 58. So, ang formula nito is score is equals to score plus or minus 1.96 times standard error of measurement is equals to 50 plus or minus 7.84 is equals to 42 and 58. So next is 99%, actually 99.74, confident that the true score falls within 50 plus or minus 3 standard error of measurement, or between 38 and 62, including 38 and 62. So, ito, sa pagkakaalam ko na formula is score plus or minus 2.58 times standard error of measurement. Kaso, yung result is iba sa nasa libro. So, I don't know kung ano ang tama. But this topic is may karugtong pa. So, Mr. Bersero will continue this topic.